Oh, there's exercise 5a. We're going to look at the factor theorem. Now, we looked at the factor theorem in year 12, so this really is not just how to learn how to use it. We're going to actually revise how to use it, because you should be good at this. So a little reminder then, factorising this should be fairly straightforward. You should be able to look at that and go, oh, hang on a bit, 15 is 5 threes, and if I have plus 5 and minus 3, that will give me the plus 2 in the middle. And then, of course, when it says solve this equation, you go, therefore I get x equals minus 5, x equals plus 3. You just change the signs. You should remember that quite happily. The second thing is, what's it say? It says write x squared plus x minus 2 as the... right. So the only difference here, rather than just saying factorise, it says write it as the product of linear factors. It means they're the same thing. It's just another way of saying factorise. So just get used to that line. That line, product of linear factors are factorised. So here then we're going to go x squared plus x minus 2 equals, and that's obviously x, I reckon x plus 2, x minus 1. And again, I don't think many of you will struggle with that, particularly when it's just x squared. That's fine. And, alright, find the roots again. Notice it sounds different. Last time it said solve, you know how to do it. Find the roots. What's that? Well, actually, it's exactly the same thing. X equals, change the sign, minus 2. X equals, change the sign, 1. So again, I'm just really on this starter trying to highlight in your mind the fact that these questions sound different, but really are exactly the same. Anyway, what are my answers? Minus, yeah, the next thing. So, wrong one, there it is. The factor theorem, and again, you saw this in year 12, and I'm going to remind you of it. There are two things basically to look out for. If you put a number like a into a function, and you get 0, I should really say this should be a polynomial function. I'll come back to that perhaps in a bit. Then x minus a is a factor. That we've just seen the backward version of that. But also, if you put a fraction in, b over a, then ax minus b is a factor. So on that basis, this is a polynomial equation, x cubed, x squared, x. So anything without being dodgy like logarithms or e to the x's or sines and coses or funny divisions, that's a polynomial. So when you get these polynomials, you can put numbers in. And usually, if you're trying to find a factor, look, it doesn't give you any clues here. It could be a variety of numbers that go into this. What we're trying to do is find a number that when we put it in, the answer is 0. Because then, if we get 0, we'll know it's a factor. Now, we're looking for numbers that go into 36 as a general rule. That will probably be your guide. So obviously, you've got 1, you've got 36. You've got 2, you've got 18. You've got 3, you've got 6. 4 and 9. And you could try any of these. So, for instance, if I tried f of, say, 2, pick one at random, it'd be 6 lots of 2 cubed, plus 27 lots of 2 squared, plus 3 lots of 2 minus 36. So if I just quickly do this, minute 1, 6 times 2 cubed is 8, plus 27 times 2 squared, plus 3 times 2 minus 36. I get 126. Now the mere fact that it's 126 tells us that was a rubbish guess. So almost like 2 is rubbish. It's not a factor. 2 is not a factor. That doesn't help me. I could pick randomly. I know that f of 4 will work. Well, kind of. I think I vaguely remember it being f of minus 4. I suppose I'm going to check quickly on my calculator. I'm going to do 6 times 4 cubed. Plus 27 times 4 squared, plus 3 times 4 minus 36. So that's when I put 4 in. Oh, 792. It was definitely minus 4 there. I'm pleased I checked that. So if I put minus 4 in instead, now you wouldn't necessarily think over here, oh, well, that negative numbers, but you do have to think about the possibility of negative numbers. And I want you to put that in. And I reckon when you do that, make sure you put the brackets in, or else you will not get the right answer. 3 times minus 4 minus 36. I reckon you'll do that and you'll get 0. And the critical thing about this is therefore x because it says minus 4, you can say x plus 4 is a factor. Now you could try other numbers. There is at least one more number here that will work, and you can have a look and see if you can find it. One other thing I'll try to get you to do as well is try that. It's not an obvious choice. 6 times minus 3 over 2 then cubed, plus 27 times minus 3 over 2 squared, plus 3 times minus 3 over 2. How on earth would think of minus 3 over 2? Now, the answer is no one really would think of those kind of numbers, and yet it works. So we need a method to allow us to do it. Let's, for the moment, just check that. 6 times by bracket minus 3 over 2 to the power of 3 plus 27 times minus 3 over 2 squared plus 3 times bracket minus 3 over 2 and then minus 36. And lo and behold, it is 0. So, no, this is the interesting thing. Because it's minus 3 over 2, therefore 2x. Now, it says minus, so I'm going to change the sign. Plus 3 is a factor. Always change the sign. If it's a minus, make it a plus. If it's a plus, make it a minus. So that's interesting, and this is this rule, effectively, being played out again. Now, this is a rule we saw at in year 12 earlier on in the chapter, in the year 12 book. Let's go through this example then and make sure we're good at this, because this will involve either long division or there's an alternative method, which is basically I call the kx method, and I'll come on to that in a bit. So show that 2x minus 1 is a factor. So notice what I will do. I will first start, it says minus, so I'm going to write plus, and it says 2x minus 1, I'm going to write f of a half. And so therefore it's 2 lots of a half cubed. And what I'm doing is I'm chucking it into this formula. Minus 5 lots of a half squared. Minus 14 times a half plus 8. And type that into a calculator, I reckon you'll get 0. And therefore, you'll need to make sure it is, don't take my word for it, but therefore assuming it is, you can then write 2x minus 1 is a factor. That's what we want. We want to show that it's a factor. Now, long division. Let's see what you remember from year 12 earlier in the year. So 2x minus 1 has got to be divided into this long expression which says 2x cubed minus 5x squared minus 14x plus 8. You just say to yourself, what do I times 2x by to get 2x cubed? And the answer to that is obviously x squared. And then you have to times these two things. X squared times a 2x gives me 2x cubed. Well, that's why I did it, because I think it's the same as that. Minus x squared. And you should remember to do this. And I told you to put it in the bracket to remind you to take away. 2x cubed minus 2x cubed is gone. But minus 5x squared, effectively minus and minus is a plus. So it gives me minus 4x squared. If you're going to make a mistake, that will be where you do it. Guarantee it. Bring down the minus 14x. And then we say, what do I times 2x by to get minus 4x squared? And I reckon it's minus 2x. And we do that multiplication trick again. Minus 4x squared plus 2x. Put it in a bracket to remind me to take away. So that minus that disappears. Minus 14 of the minus 2x. That's minus 16x plus 8. At this stage, you're hoping to get the answer, so you get the same thing. So 2x times by minus x will give me that. And minus 1 times minus 8, yeah, that works. That will give me minus 16x plus 8. So the other factors, I think really at this stage what I would do, I'd be writing f of x equal to the original 2x minus 1 times by what we call this quadratic factor. And in order to get the other factors, we therefore write 2x minus 1. And, well, we've got to factorise this. This is x plus 2 and x minus 4. Hence fully factorised. Right, I've done it. Done it there. So answers, yes, that's the same thing. Doesn't matter the order. Here's another example. Now, first of all, note Here it says plus ax, so it doesn't tell me it, but it gives me some information. So f of x then, which is x cubed minus 2x squared plus ax plus 6. If I substitute, now it says plus 2, if I substitute minus 2 into this, well, let's just do that quickly. That will give me minus 8. Minus 2 times minus 2 squared is 4. Ax, so that's like minus 2a plus 6. And the thing I was saying is, it is a factor. So when I substitute minus 2 in, the answer must be 0 because of that. That's the key. It's a factor, therefore I put the number in, change the sign, I'll get 0. So what's this give me? Minus 8 minus another 8 is minus 16, plus 6 is minus 10. Move the 2a onto the other side, become a positive. I reckon a is minus 5. So that really tells me that my function is x cubed minus 2x squared minus 5x plus 6. And it wants me to factorize it, so I'm going to have to do some division. So I've got to do x plus 2, and I've got to divide it into what I just said, x cubed minus 2x squared minus 5x plus 6. So let's do my division again. X times by x squared will give me x cubed. And x times by plus 2 will give me plus 2x squared. Put it in a bracket to remind me to take away. Minus 2x squared minus another 2x squared is minus 4x squared. Bring down the minus 5x. What do I times the x by to get this? I reckon it's minus 4x. So minus 4 times the x, minus 4x times the x gives me minus 4x squared. And I reckon minus 8x. So put it in a bracket to remind me to take away. Okay, minus 5, minus and minus, that's a plus. And again, that's where you're going to make mistakes if you're not careful. I get 3x plus 6 then. I'll bring that down. X times by that gives me plus 3. And you can see I've got a bit more space this time. I'll write it out properly. 3x plus 6 when I do it, and I get nothing left over. And that's really what you want. You want the exact answer. So with nothing left over, I can therefore write f of x equals, well, what was it? It was the x plus 2 times by x squared minus 4x plus 3. And critically, we try to factorize this. Yes, it does factorize. It becomes x minus 3, x minus 1. And having got to this stage, I can therefore say, solve f of x equals 0. So when f of x equals 0, x equals, and now I just change all the signs, x equals minus 2, x equals 3, and x equals 1. There's minus 5, we got that, minus 2, 1 and 3, yes, same thing. Now one thing I would say is, don't forget, you could have done this step using the kx method. You may remember the kx method, you may have forgotten it. All you're really doing is just saying x plus 2 times by something now has got to give me this. So I think it's got to be times by an x squared. It's got, we always write plus kx in the middle, and the other thing I can do is 2 times by something that's got to give me 6. Well, that's 2 times by 3. And what you'll notice is already I know it's going to have x squared in, and my answer did have x squared. I know it's going to say 3 at the end, and it did say 3 at the end. The only thing I've got to find is how many x's I have, so that's why I write kx. And I personally always look at the number of x squared terms in my answer. My x squared terms, I've got minus 2 of them. I can therefore minus 2 of these x squared. And if I multiply out this, what have I got? I've got x times by the k would give me kx squared. So I've got k there, and I've got 2 there as well. I'm going to multiply that. And you can see, just moving that over, k equals minus 4. So that might be a way for you to find this bracket slightly more straightforwardly if you prefer that method. You might prefer the long division method, so do that. You don't have to do both, you just have to do one method. So your job is to have a look at exercise 5a. There's a bunch of questions there. Have a go at them. Any problems? I think this should be fairly straightforward because, as I say, we saw this in earlier on in the year in year 12, and now you're just seeing it again and getting better at it. That's the idea, at least. So best of luck, and good luck.